Okay, calculus. This is from your notes. And I believe that this model's, I think it's problem 56 in your book. Let me check. 55. Okay. And I know this is hard, you guys. Hopefully you've been working hard. And if you have, it should pay off. You should do well on the test. But, this is the type of patience we have to show for problems. This really shows what kind of problem solver you are, being able to model problems like this. We want to be up to the challenge. So good for you. Hope it works out. A piece of tin that is 24 centimeters wide will be folded to create a gutter with a base that is 10 centimeters and sides that are 7. Both sides will be folded at the same angle. What angle should the sides be folded in order to maximize the amount of water the gutter can hold? I'm doing this problem fresh without looking at it, so you're going to have to give me a second here. I'll pause if I need to, but well, let's draw our 4 squares. Okay, and our work is going to take much more than these 4 squares, but at least we can use it to kind of get our problem started. We model the problem. We're going to need an equation. Maybe we can write a function. Solving is going to take a lot of space. So let's see what we can do. We have a piece of tin. What we're going to do is we're going to fold up the sides. So we have a base that's 10. And sides that are 7. And we're going to fold them up at the same angle. It says both sides will be folded at the same angle. At what angle should the sides be folded in order to maximize the amount of water the gutter can hold? Well, if we view this gutter, so we've got water sitting in here. Okay, we want the most amount of water. If we view that as a cross section, like we cut off the end of the gutter, and this is a cross section. We want to maximize the area. If you want to maximize the volume, the amount of water that can hold all together, then maximizing the area would be fine. So we need to do this. If you see the shape that we have here, the shape is a trapezoid. So we need the area of a trapezoid. Area of a trapezoid. 1/2 times h times base 1 plus base 2. So we gotta figure that out. Kind of looks a little bit difficult, but we can figure that out. You can see that base 1 is going to be 10. We don't really know how high, but we do know that we have the same triangles on each side. So each of these triangles are exactly the same. What I'm going to do is I'm actually going to draw this a little bit larger scale. Okay. Where we can see it really well. Again, we have 10, we have 7, we have 7. We actually call this angle theta. That angle will also be theta. And we have h for height. H for height. Call this d for distance. And we'll call this, we know that's 10. We'll call that x and that x. So, this really isn't too bad. There's a couple different ways to do this problem. You guys, if you see different methods, go ahead. But the problem is that right now, if we were to write the formula for the area, we have area equals 1/2 times the height, which is h, times base 1, which is 10, plus base 2, which is 10 plus 2x. Well, that's fine, but we can't have two variables. We can't have the h. We can't have the x. We need to have either h or an x. And so what I'm going to do is I'm actually going to get rid of both of them, and I'm going to write an equation that uses theta instead. So using trigonometry is a nice trick. And again, there's other ways to do this. I think this is the best way to go. So we need to figure what angle to create this at in order to do it, so we got to use theta anyways. We could use it later on, but we're going to use it now. So if you notice with theta here, this is the opposite, adjacent, hypotenuse. Same thing on the other side. Okay. So let's write an expression. Well, I could write a couple expressions. Number one, namely that the cosine of theta is equal to h, the adjacent side, over 7. So in other words, 7 times the cosine of theta is equal to h. I could also write another expression using sine. Sine of theta is equal to x over 7. Or 7 times the sine of theta is equal to x. Hey, what do you know? We got rid of our h's. We got rid of our x's. I could take that 7 sine of theta and plug it in for x. I could take that 7 cosine of theta and plug it in for h. And I have a new expression. Area equals 1/2 times 7 cosine of theta times 20 plus 2 times 7 sine of theta. And that's what I want to work with. Now I have the area in terms of theta. Let's see if we can go to work. All right. Area equals 1/2 times 7 cosine of theta times 20 plus 2 times 7 sine of theta. So my function will be area in terms of theta is equal to, if we multiply that through, 1/2 times 7 times 20 would be 70. 70 cosine of theta maybe take 1/2 times 7 times 2 times 7. We end up with 49. Cosine of theta, sine of theta. All right, so if we want to solve that, we take the derivative, we set it equal to 0. Area prime in terms of theta is equal to derivative of 70 cosine, negative 70 sine. How do you take the derivative of this? We will use the product rule. So plus, write my next space down below, the derivative of 49 cosine of theta is negative 49 sine of theta times sine of theta. Plus, derivative of sine of theta is cosine of theta times 49 cosine of theta, 49 cosine squared of theta. So this ends up being area. Derivative of area in terms of theta is equal to negative 70 sine of theta minus 49 sine squared theta plus 49 cosine squared theta. We're almost done. You remember from trigonometry that your cosine squared, you're going to have to plug in something. And you maybe remember this relationship, sine squared of theta plus cosine squared of theta is equal to 1. So therefore, cosine squared theta is equal to 1 minus sine squared of theta. That goes in right there. When we take the derivative, we set the whole thing equal to 0. So we have 0 equals negative 70 sine of theta minus 49 sine squared of theta plus 49 minus 49 sine squared of theta. When I plug that in, I got to distribute the 49 through. That's what I get. Combine some like terms. 0 equals, let's see here, we've got negative 49 sine squared and negative 49 sine squared, so we've got negative 98 sine squared theta minus 70 sine of theta plus 49. Whoop. So now we're going to solve that. We solved that in trig last year. Remember, we can factor out in this situation. Why don't we factor out a negative 7? Try to get something a little bit nicer. Negative 7 times 14 sine squared of theta plus 10 sine of theta minus 7. Now the question is, does that factor, does it not? Let me check before I waste too much time here. It does not factor. So we use the quadratic formula. A is 14, B is 10, C is negative 7. And you come up with solutions of so instead of x being our variable, sine of theta is your variable. So let's see what we get. We get 0.435. And we get negative 1.15. Okay. So, let's think about this. We have to solve for theta. Well, theta is positive. Sine of theta is positive in the first two quadrants. It's negative in the bottom quadrants. So if you think about this, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Are you going to bend this piece of tin? If we look at our original, are you going to bend this piece of tin more than 90 degrees? Well, that's absurd. So you know it's not going to be negative. Okay. We get rid of that one. We do sine inverse of 0.435. Let's work in degrees. They probably want their answers in degrees. Sine inverse of 0.435, 25.79. Again, you're not going to want to bend it more than 90 degrees. So you don't really need that angle over there. You just need the 25.79. So theta equals 25.79. So we found theta. if you look back to your original problem as we set it up, we said theta here is this theta 25.79 degrees. Well, they're wondering how much to bend it. So they're probably wondering, more this theta right there, which we would just subtract from 90. If you subtract from 90, you have 64.21 degrees. So there's a solution. 64.21 degrees. That will maximize your area. You'll be able to get the most amount of water flowing through there. Little trig, little geometry, little calculus, little everything that you've ever learned about mathematics all tied into one. I hope that helps. I know it's not easy. Good for you for trying. Good luck.